Hi everyone. In this video, we will see how to design or construct a relational database from start to finish. Which means starting from figuring out the reasons why a person or a company wants to have the database, which is called requirement analysis, to creating the building blocks of the database, and putting these building blocks together to bring the final database, not forgetting to talk about the language SQL itself. This video is the first part of this course. I encourage you to watch all the next videos because SQL is an easy-to-learn, but well-popular database programming language that has many job opportunities. There is no prerequisite to take this course. Anyone who has the basic knowledge of how to use a computer and how to put data in rows and columns can take this course and have enough practical knowledge about SQL and database at the end of this course. SQL is an abbreviation. It means Structured Query Language. Like a human being communicates with a fellow human being with various human languages, there are also languages through which a human being communicates with a computer. One of which is SQL. That means SQL is also a programming language. Some of the things that we can do on a computer using SQL are storing data, updating and deleting data, data retrieving, which means retrieving the data we stored whenever we would like to utilize it. There are various databases that use SQL as their language. For example, SQL Server Database, Oracle Database, MySQL Database. But SQL is the same for all, or SQL is a standard language. As 1 kilogram is just 1 kilogram everywhere, SQL is also SQL in all the databases. But these databases have added functionalities on the standard SQL to meet their needs. But the standard SQL remains the same for all. These databases call their version of SQL in different names. SQL Server, TSQL. Oracle, PLSQL. MS Access, JetSQL. But again, the standard SQL remains the same in all. Even if SQL is a programming language, it lacks some functionalities that other programming languages, like C++, have, functionalities such as loops. While SQL is a declarative language, the other programming languages, like C++, are procedural language, which means the code in C++ and others is executed top to bottom, as it is written by the programmer. But SQL query, for example, this one, even if the select clause is written at first, the first thing that will be executed is the from clause. SQL is not general purpose, or it is not used for various purposes like C++ is, but it is a special purpose programming language. That means those that are general purpose can be used to solve various types of problems, but SQL is dedicated to creating and manipulating databases. Any piece of information that speaks about an object, such as its height, weight, address, color, and the like, are called data. Data can be represented by a number, character, etc. Such useful information is kept and stored in some way. For example, manually on a paper, or digitally in an Excel spreadsheet. Nowadays, data is stored usually in a computer. If data is stored manually in a paper, it will be difficult to search for specific data from it, and also it is not easy to generate a report out of various paper-based data. Imagine you have data in thousands of papers, and you want to generate a report that is composed of data stored in these thousands of papers. For example, if you have thousands of papers with the grades of students, and you would like to know which students have scored high out of this many students, this is a very difficult task. So, storing data on a computer makes the task much easier. Therefore, if we want to generate a grade report, first of all, the necessary input, such as the details of the students, the courses they take, and the grade they score in each course should be stored in a computer beforehand. After this is done, generating a report will be possible whenever the report is required. Such an organized collection of data is called a database. Now let us see how to design the structure of a relational database. A person who would like to have a house built for himself will tell to the contractor what kind of house he wants to have, how many rooms the house should have, what kind of windows and doors he wants, and other specifications of the house. Then the house will be designed and built based on this information from the client. The same is true with building a database. The first thing in the process of designing a relational database is requirement analysis, knowing for what purpose the database is required. What type of data will be stored in the database, who will be using the database users, how the users would like to use the database, and so on. To make requirement analysis simple, we can divide it into different categories. For example, company requirements, users' requirements. To gather these requirements, we can speak with the administrations of the company, and we can also study paper-based documents in the company. We can also look at existing databases to get additional points for our requirement analysis. For example, if we are designing a school database, we can look at existing school databases for more information. While working on requirement analysis, we should avoid duplicate information. For example, if there are 3 similar needs or requirements, we should remove 2 of them and keep only 1. In the process of requirement analysis, if we find out that the company has 2 very different needs that have no connection with each other, we might consider having more than one database to address these completely different needs. After the requirement analysis is completed, we will design the structure of the database. A relational database stores data in tables. So first we will identify which tables the database will have. To identify these tables, we can use the requirement analysis document that we have completed. For example, if we are designing school database, we will identify tables such as students, teachers, departments, courses, and so on. We shouldn't group different things in one table. For example, students and courses shouldn't be grouped in one table. After identifying the tables, we will decide what columns each table will have. For example, in students table, we can have columns that can describe a student such as. Next, we will identify what type of data these columns will store. That means, is it number, character, or date? The columns in students table can have such data types. After identifying the tables, the columns, and the data types of the columns, we will have to pick a column that can uniquely identify a row in a table. For example, in the students table, the student name column cannot identify each student uniquely, because students can have similar names. Gender column, as well, can't be a unique identifier. But student ID can be a unique identifier, because each student will have own unique ID number that is not shared by other students. Such a column, that uniquely identifies a row in a table, is called a primary key column. So we will decide which column to use as a primary key column. Next, to control the validity and neatness of data, we will set some rules on the columns. For example, we can set a rule that forbids leaving the first name column blank. A rule that enforces female or male for gender column, and so on while inserting or updating data. Such rules on columns are called constraints. We will see in depth about constraints in another video, but for now, constraints are rules that demand certain criteria to be fulfilled in a column. Next thing is to decide which column to use as an index column. An index is a way that helps to find data quickly. We will also see about indexes in a future video, but for now, a column that is set as an index column helps us to access data quickly. As you can see, we are designing the structure of the database step by step. We have identified the tables, columns, data types of the columns, the primary key, constraints, and indexes. Now we will design the relationship among the tables of the database. In a relational database, tables relate to each other. If we take HR or Human Resource Database as an example, it has tables like employees, departments, jobs, and others. These tables relate to each other. For example, the employees table relates to the departments table because employees are assigned to work in one of the departments of the company. To create a relationship among two tables, we take the primary key of one table and make it a foreign key in the other table. A foreign key is a guest key, or a foreigner key that came from another table. In this table, Dep ID is a primary key of the departments table. To relate the employees table with the departments table, we take this primary key of departments and add it in employee table as a foreign key. After that, a relationship is created among the two tables. We will see how we can write SQL command to create such relationships later in this video. These relationships among different tables can be one-to-one, one-to-many, or many-to-many. If there are two tables in a relationship, and if one row in one of the tables relates to only one row in the other table, or if a row exists only once in both tables, such a relationship is called one-to-one. One-to-one relationship is not that common, but it does exist. Therefore, we will see how we will handle such a relationship. Let us say in a company there are two tables, one of them stores the details of individuals, and the other one stores the details of their passports. One individual receives only one passport from a country, and one passport number can only be owned by one person. This means the relationship between these two tables is one row to one row, or one-to-one. Since this is a one-to-one relationship, we can choose in which table to place the foreign key. We can either place the passport number as a foreign key in the customer table, or we can place customer ID as a foreign key in the passport table. We can describe this relationship diagrammatically as follows: one customer to one passport number. This symbol represents one row of the table which is placed by the side where this symbol is, relates to a row in the other table. When a row in one table relates to many rows in another table, or if a row exists only once in one table and many times in the other table, such a relationship is called one-to-many. For example, one state president is a president for many people who are residents of the state, but one individual in a state has only one state president, which is the president of the state where the person lives in. We can describe this relationship diagrammatically as follows: one president to many residents. This symbol represents many rows of the table, which is placed by the side of this symbol relate to a row in the other table. The other type of a relationship is many-to-many. Many-to-many relationship is a bit difficult to implement in a database. For example, if we take the relationship between students table and courses table, one student can take many courses, and one course can be taken by many students. Such a relationship is called many-to-many. But we cannot implement this relationship by simply taking the primary key of one table and placing it as a foreign key in the other table, because this will create data duplication and primary key rule violation problems later. For example, if we make course ID as a foreign key and place it in students table and try to make a many-to-many relationship, this will result in making the primary key in students table to no longer be unique, and this creates primary key rule violation. A primary key in a table should be unique and not be duplicated. If there is no unique identifier in a table, big problems will occur while trying to delete or update rows, because there will be no way to tell which exact row to delete or update. If we also place student ID in the courses table as a foreign key, the same problem will happen. To avoid this and to create a trouble-free many-to-many relationship, we will need to create another table. This additional table will store all the possible relationships among these two tables. In this new table, we can use these two foreign keys that we brought from the students and the courses table as composite primary key. Or we can create its own primary key column. We will see more about composite primary key later in this video. This new table can have more columns in addition to the foreign keys. We can give this new table any name that describes its purpose. Sometimes a table can have a relationship with itself. For example, in Employees table, one employee can be a manager of another employee. Even if this person is a manager, he is also an employee of the company. Such a relationship is called self-referencing relationship, when a table is related to itself. When we want to get joint data, or a report from tables that have a relationship, we can use joins in the query we write. We will see in detail about joins as well in another video. We have said one and many are represented by these symbols, but there are also other symbols that represent relationships. As we saw, a table can have many columns. The number of columns a table has is the table's degree. For example, the degree of table 1 is 3, because it has 3 columns. The degree of table 2 is 4, because it has 4 columns. As we continue to insert new rows into a table, the number of rows in the table will increase. The number of rows in a table is the cardinality of the table. For example, table 1's cardinality is 5, because it has 5 rows. Table 2 has cardinality 6, because it has 6 rows. The degree of a relationship, on the other hand, is the number of the tables that are involved in the relationship. The degree of this relationship is 2, because it involves only 2 tables. The cardinality of a relationship represents the number of participation each table has in the relationship. As we saw earlier, this can be 1-to-1, 1-to-many, or many-to-many. The cardinality of this relationship is 1-to-many. The cardinality of a relationship can be represented as follows. The video will continue. Before that, if you like this video and find it helpful, please like and share with others. And to receive a notification every time I upload a new video, please click the subscribe button. Let us see some additional points about primary key. As we saw earlier, we can assign one of the columns in a table to serve as a primary key. That means we are setting a primary key constraint or rule on the chosen column. Therefore, it is not possible to insert duplicate values in a column that is assigned to be a primary key. EMP-ID is a primary key in the Employees table. But the values in the primary key column, as you can see, are just unique numbers that are used to serve as employee ID. That means these values have no special meaning in reality. Such a key that has no direct connection with the data, but is used as a unique identifier, is called a surrogate key. Mostly consecutive numbers are used as surrogate key. But there are keys that have a direct link with the data. For example, if we use email address or mobile number of employees as a primary key, such a key is not a surrogate key, because it has a direct link with the employee. Such a key is called natural key. The other one, which we saw earlier, is composite key. It involves more than one column. These columns cannot make a row unique separately, but together, they can make each row unique. In this table, student ID and course ID together are composite key. If one is missing, as you can see, the other one alone cannot make a row unique. One table can have only one primary key, which means we cannot set primary key constraint more than once in a table. But one primary key can have one or more columns. For example, schema represents the full or partial design of a database. That means it represents the design of the tables in a database, the relationship among the tables, columns in a table, constraints in a table, other objects in the database like views and stored procedures. For example, HR schema of a company database. Schema doesn't have data in it, it is just a database design. Therefore, in a database, there are schemas and users that have created the schemas. In SQL Server, if a user doesn't create a schema or connect to a schema, SQL Server will connect all the database objects created by this user to the default DBO schema. Therefore, in a normal procedure, one user creates a schema and keep all the database objects under this schema. After a database is created and ready for use, its content will change from time to time. For example, when new data is inserted, or existing data is updated, or when a new database object is created, the content of the database will change. In a school database, if students' table have 1,000 rows in the first week, it can have 2,000 rows in the next week. Such things continue to change the content, or the state of the database. So, a state of a database at different times is called instance of a database. In the school database example, the first week can be instance 1, the second week instance 2. This is just an example. An instance of a database can change in days and hours. And also, not only one table will have changes, but many tables and other objects can change as well. But database schema doesn't change that much, it might not even change at all. But as we saw, instance of a database changes time to time. As we saw earlier, tables of a database have a relationship with each other. If there are many tables in a database, it will be difficult to know which table is related to which. So, to see the relationships among the tables in an easy way, we use ER, or Entity Relationship Diagram. It is called Entity Relationship Diagram because tables are called also entities. This ER diagram has only 2 tables. But databases can have many tables, this is just an example. ER diagram represents tables with a rectangle, columns with oval, relationships with diamond shapes. There is also a schema diagram. Schema diagram is more elaborated, which means it has additional details in it, like primary key and foreign key information. It also shows the tables, their relationship, how they are related, which means with what foreign key they are related, and the cardinality of the relationship. In this schema diagram, PK represents the primary key and FK represents the foreign key. As we saw earlier, a foreign key in a given table is also a primary key in another table. In this case, Dep ID is the primary key in the department's table, and a foreign key in the employee's table. Therefore, these 2 tables are related through this foreign key, Dep ID. In this schema diagram, we see a pair, PK-FK, which means they are a composite key, a key composed of more than one column. Student ID and course ID together are serving as primary key in the table students' courses. Some tools can be used to prepare both ER diagram and schema diagram, but we can prepare these diagrams also manually on paper. When you start a job in a company, if all these designing processes are already completed, you can request these diagrams from the company to see how the tables are related to each other. Some developers also include comment columns for further information, so you can check out those as well. Using the finished ER and schema diagrams, we can create the tables and their relationships with SQL commands, for example. So relational database design, or structure of a relational database includes all these. This was the first part of this SQL video series. Thank you for watching. If you think this video was helpful, please like, subscribe and share. Hope to see you next time. Bye.